Welcome to lesson 4 of unit 12. We're going to talk about the probability of compound events. And compound events are just when two or more events occur at the same time. Okay? Now, it's a union or intersection of two events. Now, a union is all outcomes in either event A or event B. So, for instance, just to give you some context, because a lot of people struggle with this if they don't have an actual event. Let's say A is when you eat Cheerios. And let's say event B is you get an A on a test. So the union is all the outcomes in either event A or event B, okay? So event A, eating Cheerios. So you might eat Cheerios, you might not. And event B, you might get an A on a test, you might get not. Sometimes A and B happen at the same time. So for example, you might have eaten Cheerios that day and you get an A on a test. You might get eating Cheerios for breakfast and getting an A on the test the same day. That is called the intersection, where both events happen at the same time. Those are the outcomes where both A and B happen. Okay, and it's demonstrated right here, that little red overlap, that is the intersection right there. Now, sometimes you could eat Cheerios and not get an A on the test. That would mean that the two ways that could happen, they never touch. So if that happens, we call that being mutually exclusive, okay? Mutually exclusive events. No outcomes are in the intersection of A and B. So then, if A and B are mutually exclusive, then the probability that A or B happens is the probability of A plus the probability of B. So let's say that A in this case is that you are a UND fan. You like the University of North Dakota in Grand Forks. And let's say that B, that you are intelligent. Now we obviously know that A and B are mutually exclusive, which means they can happen at the same time. You can't like the University of North Dakota and be intelligent. So that way, the probability that you are both a fan of UND and intelligent would just be the number of ways of the probability that you're a fan of UND plus all the ways that you could be intelligent. Now, of course, I'm just poking fun here. I went to NDSU, which is the rival school of UND, so I'm just teasing. You can be a UND fan and be intelligent, but I just thought you'd get a laugh out of that. Sometimes A and B are not mutually exclusive, which means they can happen at the same time. Okay? So let's talk about this in another way. Let's just say A is that you like to eat vegetables. And let's say that event B is that you are overweight. Now, is it possible for you to like vegetables and be overweight at the same time? I would say yes, it is possible. So the probability that you either like vegetables or you are overweight would be the number of ways that you could like vegetables. So the probability that you like vegetables, the probability of A plus the probability of B that you are overweight minus the probability that you like veggies and you're overweight. Probability of A and B. So it's possible. You could like vegetables and still be overweight. It just depends on you exercise or not. So this is just because you're going to count them more than once. So think of it this way. Look at the picture. Remember what I said A was? A was you like to eat vegetables. Now let's say that 1, 2, 3, 4, 5, 6, 7, 8. There are 9 ways, or 9 people who like to eat vegetables. And let's say that then you count how many people are overweight. 1, 2, 3, 4, 5, 6, 7, 8. And you see that when I counted the 8 who are overweight and the 9 who like vegetables, there are some people in the middle who have both characteristics. They both like vegetables and they're overweight. That happens. So if I counted all the dots, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4, 5, 6, 7, 8, I counted these 4 twice. There are actually only, think about that, 9 plus 8. What's 9 plus 8? That's 17. But how many people are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are only 12 people. So obviously it couldn't be 17 total, right? Hopefully that makes a little sense. Let's go on to the next examples. One 6-sided die is rolled. And so if you don't know what I mean by that, here's what a die looks like. It's rolled, right? Now it's asking, what is the probability of rolling a 3 or a 5? Now, first of all, I need to ask myself, is this mutually exclusive? What I mean by that, if it's mutually exclusive, that means can they both happen at the same time? Can I get both a 3 and a 5 when I roll one dice? And the answer is no, I cannot get that, so it is mutually exclusive. I can't get both a 5, so this is, yes, mutually exclusive. I can't get both at the same time. So then the probability, we just have to count the number of ways I can get a 3 or a 5. So the probability of getting a 3 or a 5 would be the probability of getting a 3 plus the probability of getting a 5. Well, what's the chance of rolling a 3? How many sides are there? You can. I'm going to make this slow down so you can see it. There are 6 sides. Top, left, right, back, front, bottom. There should be 6 sides. And there's only one 3 on there. So it's 1 out of 6 for the 3 plus 1 out of 6 for the 5. So that'd be 2 out of 6. That's 1/3. Excuse me, or that is 33%. So that is the answer for the first part. Now let's say one 6-sided die is rolled. What is the probability of getting a multiple of 3 or a multiple of 2? Multiple of 3 or a multiple of 2. Is it possible to get a number that is both a multiple of 3 or a multiple of 2? What are the multiples of 3? Okay. Which one of those are on the dice? 3 and 6 are. Because it doesn't go past 6. 1, 2, 3, 4, 5, 6. What are multiples of 2? 2, 4, 6. There is an overlap, right? We would count the 6 twice. Right? 1, 2, 3, 4, 5. But there's only 4 different answers. So the probability of getting a multiple of 3, so I'm going to say mult 3 or mult of 2, abbreviating multiple, is going to be equal to, all right, it's going to be equal to the probability that I get a multiple of 3 plus the probability to get a multiple of 2 minus the probabilities that are multiples of both, 2 and 3. So how many multiples of 3 are there? 2 out of 6. 3 and 6 are both multiples. So that's 2 possibilities out of the 6 on the dice. Plus, there are 3 possibilities out of 6 that are multiples of 2. But I counted the 6 twice, so I have to subtract that 1 possibility out. So really, I only have 4 out of 6. 2/3 or 66%. Okay. Now, let's find the probability to get a spade or a 10 in the standard deck of cards. First of all, can I get a spade and a 10 at the same time? I can. So this is not mutually exclusive. I could get a 10 of spades. That's possible. Okay, so the probability of getting a 10 or getting a spade, it's a spade if you didn't know, that's the shape it is, it's like a shovel, is the probability of getting a 10 plus the ways I can get a spade minus the one time it happens twice. All right? 10 of spades. Now think about that, because how many different 10s are there? There's 4 10s. There's the 10 of hearts. Sorry, that's diamonds. 10 of hearts, 10 of spades, 10 of clubs. Those are the 4 different ways it can happen. It's the clubs and then 10 of spades. Now, and then obviously with the spades, I have to count ace all the way through 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. And so obviously I would count the 10 twice. I'd count it when I was counting the 10s, and I would count it when I was counting the spades. So there's an overlap. That's why I have to subtract it out. It would be 4 out of 52 for the 10s, because there's 4 10s. Then there are 13 spades. And I have to subtract the one card that is both a 10 and a spade. 1 minus 4, that's 16 out of 52. Let's simplify that fraction by dividing by 4. It'd be 4 out of 13. If I divide in a calculator, which I'll do that quickly on screen, 4 divided by 13, it'd be about 30%, 0.308 or 30.8%. Good. Go to the next one. In a poll of high school juniors, 6 out of 10 took a French class and 11 out of 15 took a math class. 14 out of the 15 students took French or math. What is the probability that a student took both French and math? So remember, is it possible for you to take both French and math at the same time? Well, it should be obvious, yes, because it says in the question that you can. So the probability that I took French or I took math should be equal to the probability of French plus the probability of math minus I took the probability of French and math. So I would be double counting it. What's the probability I took French or math? Well, it says 14 out of 15 took both. Or one or the other, excuse me. 14 out of 15 took French or math. What is the probability that they took both? Well, what's the probability they took French? 6 out of 15. Plus, what's the probability they took math? 11 out of 15 took math. Well, obviously that doesn't add up. 6 plus 11, so I have to subtract away some number out of 15, right? So 6 plus 11, 14 out of 15. 6 plus 11 is 17 plus minus the one I had to take away. 17 minus x over 15. If I multiply both sides by 15, I know 14 is 17 minus something. And you didn't have to do all this algebra. You could see pretty clear right away that the x has to be 3. So 3 students took both French and math. Okay. Now the last thing we're going to talk about in this video is the complement. The probability that A does not happen. So a complement A does not happen. So when you see this, A apostrophe, that means A does not happen. And again, I read that A prime. A prime means A does not happen. The probability of A not happening is 1 minus P of A. Remember what 1 is? That's 100% minus the probability of A happening. So basically, what would it be? If the probability of A is 20%, what's the probability of A prime? Well, of course, it has to add up to be 100. So it would be 100% minus 20%. It would be 80%. So if it happens 20% of the time, it doesn't happen 80% of the time. Let's say, for example, a card is randomly selected from a standard deck of 52 cards. Find the probability the card is not a king. Probability of not king would be 1 minus the probability that it is a king. Well, how many kings are there? There are 4 kings out of 52. 1 minus 4 out of 52, that's 52 over 52, minus 4 out of 52. Well, that would be 48 out of 52, or in other words, 12 out of 13. Not an ace or a jack. Well, you'd have to take away the aces and the jacks, and so that would be minus 8. So we'll talk more about this in class. I hope you have a great evening. We'll talk about this question specifically when you get to class tomorrow. This is an interesting question. Have a good night.